Today we are excited to host David Leach, Principal Separation Scientist with United Kingdom-based Reach Separations. Reach is a growing outsource provider of chromatography for the purification and analysis of small molecules, specializing in high-performance liquid chromatography and SFC for chiral and achiral separations. Reach handles over 1,400 samples per year for pharmaceutical, contract research organizations, agrochemical, and academia. Specifically, David has over 15 years of experience in SFC, preparative purifications, and managing the flow of projects through the laboratory. He's responsible for investigating improvements to working practices through procedures or equipment investment, and we're very lucky to have David present about his work and experience of using the new AccuPrep SFC. David will be presenting about preparative supercritical fluid chromatography, features and benefits for the modern lab within the context of his investigation of the AccuPrep SFC system. At this point, it's my pleasure to hand it over to David.
Thank you for the kind introduction, and thank you for joining this webinar today. As has just been said, my name is David Leach. I'm the Principal Separation Scientist at Reach Separations, and I'm responsible for all the projects going through our UK labs. Just to give everybody a feel for what I'll discuss today, I'll talk a little bit about our organisation and what we offer as a service. I'll then go into an overview of SFC for those in the audience who may be less familiar with the technique, and discuss the benefits of SFC. I'll then go into the crux of the webinar in outlining the features of the AccuPrep SFC, what configuration options are available to perform your purifications, and how these compare to other systems in our labs and on the wider market space. A little introduction to us at Reach Separations. We are an outsourced provider of purification and analysis of small molecules by chromatographic means, so HPLC and SFC, but we also have some GC capability at our site in Strasbourg. We started out in 2011 at BioCity in Nottingham in the UK. A little bit of a history for you. The site was previously owned by Boots UK, and the Stuart Adams building where we reside is named after the co-founder of ibuprofen, which was developed on site. In 2022, Reach opened a second site in Strasbourg in France as well. As an organisation, we handle around about 1,400 discrete samples per year, so this is not including arrays or well plates or anything like that. The majority of our work is doing chiral purifications, and of those, the majority of it we try to do by SFC for reasons which I'll come on to shortly. We still do use HPLC, it does have its place just for workflow reasons, and we do occasionally get better separations on HPLC, but we always try to go for SFC where possible. A smaller amount of our work is doing achiral purifications, and as you'll see on the slide, we use SFC less, and that is mainly due to workflow again. A lot of our SFC instruments do get used for chiral work. We do sometimes still find that reverse phase HPLC gives us better resolutions, particularly chlorine and impurities. Also, the current setups of our SFCs don't lend themselves particularly to achiral SFC, which is what's attracted us to the Teledyne system in the first place. Our clients are probably quite a broad market space, as you'll see, big pharma, CROs, agrochemicals, and academia. We'd like to take advantage of all the benefits that SFC offers us in terms of speed, reducing solvent consumption, and eliminating the requirements to remove water from our samples during post-processes, which I'm sure you'll all appreciate can cause a plethora of problems. Our prep SFCs are primarily set up for chiral purifications, which is why we were interested in what the AccuPrep SFC could offer us to be able to utilise SFC more, and hence why we wanted to get involved in the development of the system. The systems we have in our labs are from the vendor list at the bottom there, and all of them are configured in such a way to collect intergerans from a fraction valve. Due to our current systems and the experience we have, we felt that we could contribute in a good way to the development of the AccuPrep SFC. Okay, the next few slides are a brief introduction to SFC. What is it? It's seen as an analogous technique to normal phase HPLC, in that the non-polar portion of your mobile phase is replaced with supercritical CO2. It's also thought of as an orthogonal technique to reverse phase HPLC, which has a wide polarity compatibility and is also able to remove close running impurities. And this has been widely proved to be the case with SFC. You also get improved chromatography due to a higher column efficiency with more theoretical plates. And it's also seen as the greener choice, as we've discussed already. Supercritical CO2 is used as part of the mobile phase in SFC. Why are these advantageous? Well, supercritical fluids have the solubilizing power of the liquid due to its high density, and also also has a low viscosity of a gas, which is able to achieve high flow rate. SFC has a slightly different separation mechanism than normal phase HPLC. Why is that the case? Well, due to the high CO2 diffusivity value in comparison to hexane, hexane tends to sit in the pores of a stationary phase for longer, whereas CO2 diffuses in and out more quickly. It can be quickly replaced by the analytes. This increases the usable surface area of the stationary phase, and therefore increases the number of theoretical plates, which gives better peak resolution. If we move on to an SFC instrument, to just give you a brief outline of what one will look like. If we start up, we consider a HPLC system first. So over on the left, at the start of the system, we can have one mobile phase pump and pre-mix our solvents, or we can have two pumps and mix online. Then we have the injection system to introduce our sample into the flow path. And in this example, we have the total flow, mobile phase flow, going through the injection system. Follow this, you have the column, and then the detection means, which in this case we've got UV. And then lastly, we have the fractionation valve with the collection vessels. Now, a slight adaptation to this is we can have just only the B solvent here passing through the injector, as opposed to having the total mobile phase flow going through the injector. Now, the reason for this will become a little bit clearer when we look at the SFC in more detail. And this setup can be considered an ACD-like injection. Now, this can be a slight blessing and a curse. It helps to keep low soluble samples in solution when you're trying to introduce them onto your column. However, with low percentage mobile phases, this can be quite problematic due to having a low flow going through your injector. Okay, if we now exchange the hexane portion of the mobile phase for CO2, we're now getting something closer towards an SFC system. When we do this, we then need to introduce a back pressure regulator for the later on in the system, as depicted here, and that's to maintain the CO2 in its supercritical state. What's not on this slide as well is that we also need to keep the injector, the column, and the mobile phase at an elevated temperature to keep the CO2 in its supercritical state. If we're now focusing on the fraction collector, you'll note here that the fraction collector is post BPR, so we now have gaseous CO2 to remove from our system. And we do that with a gas liquid separator. Now, the configuration on many systems is to have a gas liquid separator on every collection point, as we see here, so after the fraction collection valve. The second option is to have the single GLS pre-fraction valve, as depicted here, and that's indeed what we have on the ACIPREP SFC. So if we go back to the overall layout of the SFC system here, you can see in the picture here. There are other additions that you need for an SFC system, such as chiller blocks on the CO2 and heat exchangers, but the main crux of the flow path is depicted on the slide just here. If we now focus back in on the gas liquid separators, this brings us on quite nicely to some of the features of the ACIPREP SFC system. As I mentioned earlier about the two possible configurations for a GLS, the first one being having one GLS per fraction valve. In this situation, you very much reduce the chance of any cross-contamination of your fractions. However, due to the flow intermittently passing through each GLS, you can get deposits of material on the internal surfaces of the GLS, particularly for low soluble samples. Now, examples of this type of configuration in our labs are shown here. On the Virgin multigram on the left-hand side, we have got glass liquid separators, so they're quite nice, easy to see any build-ups of any material. On the CPA Prep 100, the glass liquid separators are housed behind this blue styrofoam here, and so you can't see them. So you do have to be quite careful of confidently clean down procedures. Now on this system, these are both examples of what we call impact separators, whereas the gas-liquid mixture impacts on the surface, causing the gas and the liquid to be separated. Okay, the second option is to have a single GLS pre-fraction valve. Now the advantage with the design is you get flow constantly running through your gas-liquid separator, and this almost acts like self-cleaning. However, on a downside to this is you could get risk of cross-contamination of the fractions you've worked hard to separate, and that all depends on the design of the liquid separator. Okay, if we actually look at the GLS on the AccuPrep SFC in more detail, what I will say at this point is that the physics of how a GLS works is almost a webinar in itself, and there are people that are a lot more informed than me on how these things work. However, just to give you a brief outline, what happens is the CO2 solvent mixture is introduced into the GLS just at this top portion here. The first stage of the process is an impact separation against the glass surface in front of us. What happens next is then the mixture is accelerated around these fins around the outside of the GLS, which then creates a cyclone effect, resulting in the CO2 gas being exhausted at this point here. What you're then left with is your analyte and your remaining CO2 co-solvent, which is forced out of the GLS at the bottom just here and towards onto your fractionation valve. And if I run the video for a short period of time, you'll see solvent coming up in the top and being expelled out of the bottom. One more thing to consider here is that there is a minimum co-solvent flow requirement for any GLS to function effectively, and it's around about 10 mils a minute in this case. So depending on your purification conditions, there is a potential to be below this value. A feature on the AccuPrep SFC is on top of the two main mobile phase pumps in the system, there's a third makeup pump built into the system that feeds directly into the mobile phase stream prior to the GLS. This makeup pump is activated automatically when the system calculates that the solvent flow is too low, and this requires no extra intervention from the user. Moving on to another feature of the AccuPrep SFC, we have a CO2 flow meter built into the system. Now, liquid CO2 is a very highly compressible fluid. Now, the CO2 pumps on a system are actually adapted HPLC pumps. So the output flow you get is much lower than the pump set point. Another problem you can have is that the CO2 flow can actually fluctuate depending on what your supply pressure is. Now, what this can result in is changes into the overall mobile phase composition, which can lead you to inconsistent chromatography. The way you resolve this is with actually having with a mass flow meter. And on the AccuPrep SFC, what this flow meter does, it feeds back to the CO2 pump, and the CO2 pump speed adjusts itself to maintain a constant flow. And this is fully integrated on the AccuPrep SFC. If we move on to the configuration options we have on the AccuPrep SFC, we have two collection configurations. The first one being is collection into durand via a fraction valve, which is similar to the slides we saw earlier, and is also similar to the other configurations we have on other systems in our labs. Now, this setup is ideally suited to doing chiral separations or single peak achiral separations. The second option we have is a collection into an open bed fraction collector. This is the option that will facilitate more achiral separations by SFC, particularly if we're collecting multiple components, being able to collect impurities into individual fractions or performing fractionation experiments. We also have two injection possibilities on the SFC. Now, the first one is injecting through what's called the external probe, which draws your sample directly into the injection system, much the same way as other systems on the market. Now, we have the option to collect using the fractionation valve or the open bed fraction collector, but you have to bear in mind that this injection pathway is required if you're performing stacked injection process and collecting into the open bed fraction collector. As you can imagine, the unit will get very confused when trying to inject and collect at the same time. There is the option of injecting through the autosampler when not doing stacked injections, and this is particularly useful when queuing up the purification of multiple samples. And once again, you have the option to collect your analytes using the fractionation valve or the open bed fraction collector. I have to admit that queuing of samples is not a feature that we've used in our labs on this system, as it doesn't really fit with our workflow, but I'm sure you can imagine there are situations in other labs where this feature will be useful. Okay, just give you a few pictures to look at. Those who are familiar with the AccuPrep HPLC, the SFC unit, the main unit, is very similar footprint to the HPLC. It's slightly modified to incorporate the column oven and some other components required for SFC. So at the top, you have the control box with the integrated touchscreen, much like on a HPLC. Towards the middle, you have the column oven, and down at the bottom, you have where all the pumps are housed. If we look at a wider picture of the system, over on the left you have a chiller, which is required for chilling the pump head on the CO2 pump, and also over on the right we have the fraction collector. The one you can see in the picture here is what's called a 4x2 fraction collector, and there is a slightly smaller one available as well. But hopefully this should give you a good feel for the overall footprint of the system. If we look inside the column oven drawer, we have a 6-position column switching valve, and also the injection system is housed in here. Keep the temperature of all those components nice and stable, as I mentioned earlier. Down at the bottom, we have the two main mobile phase pumps, and also hiding around the back is the makeup pump. The left-hand pump is a CO2 pump, which requires the cooling block on the heads of the pump. These particular pumps are SSI pumps, which we do ourselves have on other systems in our labs, and we have actually found these pumps to be very robust pumps indeed. We move on to some of the software features. It's very difficult to discuss all of the features of the software in this setting. It's much better to be in front of the unit, but we'll do the best we can. One feature I would like to highlight is when performing stacked injections, there is the option of being able to adjust many of the stacking parameters on the fly. What this means is you don't necessarily have to completely develop a process using single injections before you're setting up your stack, and you can almost develop your process on the fly, thereby saving some valuable time, valuable solvent, etc. Another feature is the data visualization. This is not the exact readout you get on the screen, on the live screen, but it's very similar, and it enables you to check the fractions. This example is a collection into durands, and you can easily check that each isomer is collected into the correct vessel before you continue with your post-processing. This is another example where we've collected into fraction tubes, and the color coding gives you a really nice representation of what fractions have collected into which tubes. Finally, here are some typical results on a range of samples. Without going too deep into them, you can see we've achieved pretty good yields, recoveries and purities using the various collection modes available. And indeed, I wouldn't really be sitting here discussing the system if this wasn't the case. And finally, to conclude the talk, we have a very, very user-friendly system, really easy to use. And some of the software features that I haven't mentioned almost makes this system a semi-walk-up system if you set it up in the correct way. Some of the hardware features allow for really consistent chromatography and really high yielding purifications via various collection modes. Software is really intuitive and allows for rapid development of a purification process. And we ourselves can envisage this being a very useful tool in utilizing SFC for a wide range of purifications. Just finally, we do have some on-site demo days available here at our UK labs at Reach, and you can get in touch with the Teledyne ISCO guys to arrange that if you wish. And finally, it just leaves me to say thank you very much for listening, and I'll be happy to take any questions. Thank you.
Thank you, David. Just as a reminder to everybody, you guys can use the QA function in Zoom to submit any questions to David and myself here, and we'll be happy to answer them. So we've got a couple to start with, and this one is probably maybe more targeted towards me. Is MS triggering available? Not yet. That's in development right now. Once that's available, hopefully later this year, we'll have a separate webinar on that. So just to answer that question. The other question here, David, for you here. So can you describe how you supply CO2 to your lab and your instruments, and the importance of the mass flow meter, for your SFC applications?
Yeah, sure. So we use high pressure liquid withdrawal cylinders. So they're usually seated around about 60 bar pressure. Now what happens is, as you draw CO2 out of these cylinders, you naturally get a pressure drop inside the cylinder. Now you can sort of mitigate this a little bit by having jackets around the cylinders to keep them warm. But eventually, as you empty the cylinders, you will get a pressure drop. Now the result of that is because when you get a pressure drop on your inlet pump, you'll get a drop in flow on the outlet of the pump. So the consequence of that, you will then get a change in mobile phase composition. So to mitigate against that, this instrument has the flow meter installed, which feeds back to the pump. So the pump is never running at a constant rate. It actually always changes depending on what the mass flow meter tells it the amount of CO2 that's running through the system. So the consequence of that is you maintain a constant mobile phase composition, and therefore you get consistent chromatography.
Perfect. Another question. This is more related to achiral separations, but how does the GLS and the open bed fraction collector enable users to explore more explore achiral purifications, where SFC normally has been targeted towards chiral purifications in the past?
Yeah, sure. So just saying, so earlier on in the talk, described about the GLS setups that are on systems that are mainly suited for chiral. So you have a GLS on each fraction collection position. That particular setup doesn't lend itself very well to doing achiral purifications, particularly if you want to do impurity isolations or even just fractionate across a gradient and try to see what exactly you've got in your sample. You need an open bed, which is a technique which is what we use traditionally with reverse phase HPLC. And to have an open bed, you need the setup where you have the single GLS being there prior to the fractionation valve or the open bed. So this current setup opens up a possibility to explore more achiral separations by SFC.
Another question. I know I talked to a lot of users, and there seems to be a lot of curiosity with modifiers to the use of different modifiers with the co-solvents and things like that. What are some traditional modifiers that you use in your guys' normal or in your processes on a regular basis, and what co-solvents do you guys use as well?
Yeah, so in terms of co-solvents, we traditionally go for the alcohols, so usually methanol or ethanol. We do use IPA, isopropanol, beg your pardon, if we need to. And traditionally, because of the nature of the compounds that we tend to deal with, we tend to majorly go with base modifiers. So things like ammonia or isopropylamine or diethylamine if we need a slightly stronger modifier. That's all well and good until you end up with an acidic compound that's carboxylic acid, for example. And if you've then in acid modifiers, you've then got alcohols and acid mixtures, and it opens up the possibility of doing transesterification or esterifications. In that scenario, we then revert to using acetonitrile as a co-solvent, and then we can still use acid modifiers.
Excellent. Yeah, that's a good point about the transesterification with the alcohol co-solvents. Another thing I run across with some of the customers we see in the lab is seems like they're interested in water being used with some of these co-solvents. Do you have any experience adding water as a modifier to the co-solvent at all?
It's not something we've ever done. I must admit, I've seen many presentations, opens up a lot of applications in SFC, particularly going for doing peptide purifications with just a couple of % water in the mobile phase. I think it just helps increase the acidity of the mobile phase a little bit more, but it's not something we've actually physically tried in our hands.
Excellent. No, that's good information. It looks like it's a growing area of interest from users. So hopefully we'll be able to get some more use in some of the labs with the AccuPrep SFC being available and the ease of use. So I don't see any other questions. I want to thank David for presenting, and also for working with us so closely in the development of the system and testing and continuing to help us by being a demo site for us in the UK. So I do want to remind our users, if you're in Europe or the UK, you can visit Reach Separations at one of the UK demo days that you can sign up for through Teledyne ISCO, and visit with David and see their lab set up and see how the system's used in their processes, and just really appreciate you guys working with us so closely. You guys have been great partners.
No problem at all.